Welcome to Lab 2. In this video, my goal is to show you how to compile and simulate your first assembly language program. Now, I assume that you have the Lab 2 handout, so we're going to go ahead and start up codewarrior. We're going to create a new project. It remembers the last microcontroller you used. You don't have to change anything there. Hit Next. Deselect C, select Absolute Assembly, and we're going to name this Lab 2. So I'm going to go ahead and call this Lab 2. Hit the Next button, Next, and then Finish. Now, codewarrior creates a project for you, and this main.asm file is the file that you're going to put in your source code, your assembly language. So let's double click on that, and notice that what codewarrior did was actually fill in a whole bunch of stuff for you. Now, it also puts in a sample assembly language program. This assembly language program begins at this LDS statement right under entry startup, and then all the way down to just before the interrupt vectors area. It also has a bunch of other things up here that's called startup code initialization. We don't want to delete or alter that in any way. But since we're going to write our own assembly language, there's no reason to keep what they put in the assembly language area. So let's go ahead and highlight everything above interrupt vectors and then just after entry startup, and then we're just going to go ahead and delete that because we're going to enter our own program in this area. We don't want to modify anything else. Now I'm going to use the program that's in the example in the Lab 2 handout, and to save time I have it here in Notepad, and I'm just going to go ahead and copy that and paste that right here into the same area that we have. And I'm going to go ahead and do that right now, and there it is. Okay, so now you're going to go ahead and write your own version of this. But notice that in every program I'm going to require you to put in this header information, and anything under the header I usually have a semicolon, of course, before any of those statements because it's ignored by the assembler. Those are considered comments, and they show up as red. They are ignored by the assembler. And then the program actually starts here at this statement LDAA pound 50. That says load accumulator A with the value 50 hex. And notice that I have a comment over here, A equals 50 hex. Also notice that I've tabbed over from the left side. You need to do the same. Tab over about the same distance as we had initially with the assembly language program that was deleted. And then we tab over again, put a semicolon in, and put a comment on each line. I also skip a line between each assembly language statement to make your program more readable, and I advise you to do the same. So at this point the program has been entered. Now remember, never write a program until you have a completed flowchart. Before we go ahead and simulate, I would like to also show you how to get a program listing from the compiler. A listing is a set of code that's generated from the compiler that shows not only your source code, but also the machine language equivalents for each of these statements. Last week you did machine language, this week assembly language, but the compiler is extracting the machine language from each of these statements. And you can see that in the listing, and that's what you need to turn in. You never turn in source code. Now to go ahead and create a listing using codewarrior, what you have to do is come over here on the left and press on the Targets tab. Double click on the standard, go down to Assembler for HCS12, hit Options, and then click on Generate a Listing File and hit OK. And then hit OK again. Later on in the video I'll show you how to extract your listing file so that you can turn that in. Alright, we are ready to go ahead and simulate this program. We go ahead and hit the Simulate button just like we did last week, and we get the same little pop-up program that shows us a couple of new things. On the top left here we have the actual assembly language that we created today. We also have our registers that we had before, and notice that this assembly area right here has our program once again. This is the actual disassembled code from memory. So let's pull up the memory window for an instance here, and let's scroll down to location 4000. So you go under memory address, we'll type in 4000, hit enter, and notice that this is the machine code that was generated from our assembly language. For instance, 8650. That machine code stands for LDAA pound 50 hex. And we notice that that is located at location 4000, which is the first statement in our program. And notice that the program counter is sitting at 4000 conveniently for us to execute. So, just like last week, we're not going to blindly start hitting the single step button. We're going to predict what happens first. The first statement says load A with 50. So I would expect that the accumulator A over here is going to go to 50. Right now it has the value CB, which is a random value. So we hit single step, and sure enough, A is 50. The next statement says B equals 20. Single step, notice that B went to 20. Now we have subtract B from A. We would expect A then to go from 50 to 30 because 50 minus 20 is 30. We single step, and sure enough, A is now equal to 30. And finally, the last statement is A equals A plus 1. We would expect A to go from 30 to 31. Now, this last statement says no operation. That statement does absolutely nothing, and it's really not required in our program, but I use it as kind of a placeholder so that we have one last statement to jump to after this last single step. So at this point, the program is complete. And you notice that as we step through, this blue line over here in the top left went down one line as we proceeded to debug or single step the program. That's a huge help in understanding what actually happens. So I advise you to single step and predict what's going to happen so that you can understand what your program is doing. This concludes showing the simulation. If you have errors in your program, you'd have to go back through, and we'll close this window, fix the errors here in the assembly language, and then simulate once again. With this program complete, to turn in the listing, I'll show you how to do that. The listing was generated, and you go under My Documents, and here's the My Documents area. And notice that Lab 2 has been created for you as a folder. So we open that up, and it has a number of things. Your source files are contained in the source folder, but the listing is contained in the binary or bin folder. We open that up, and we notice that we have main listing. So we go ahead and open that, and this is a rather large file. Please do not turn in this entire file. There's a lot of extraneous information in this file that we will develop over the course of the semester. Your file or your program is contained at the very bottom of this file. So notice if we scrolled all the way to the bottom, we see the code that we created. Here's the header and so forth. Notice that LDAA pound 50 here on the left has its object code. Under the object code column is 8650. That is the machine language equivalent of load A with 50. Last week we actually entered this machine code by hand. Now notice the assembler does it for you automatically. A very convenient tool. Notice also that it has a location here as 4000. So at location 4000, 8650, and then the next machine language statement is at 4002, which is C620, and so forth. So this listing is very important if you're debugging a program. Never ever turn in anything except a listing for a lab or a homework assignment. I will not accept source code. But only cut and paste this end portion, which is your code, not the entire listing file. Also, it would be very good to turn in the file printed landscape so that there is no wrapping. It's very hard to read when things wrap, and as you can see, this is actually in kind of a landscape format as it is. So please turn in all listings as landscape printed. This concludes the video in Lab 2. Thank you.